Okay, this one's kind of a tough one. Number one, you could go a couple different ways. If you are the St. Louis Cardinals, you win many championships, World Series, or if the St. Louis Cardinals play, they will win. So either one, I'm going to go with if you are, I'm going to say space, the Cards, then you win many World Series. And the converse is you just switch it. If you win many World Series championships, then you are the Cards. And that's not necessarily true because the other teams have won many championships. Okay. Do it again. Okay, so matching vertical angles. Vertical angles, C, share a vertex and are congruent. Linear pair angles. That would be G. They form a straight line, 180 degrees, and share a side. They're also supplementary. Alternate interior angles. A, inside parallel lines and congruent. Consecutive interior, consecutive interior angles, D, inside and supplementary. F is outside parallel lines and supplementary. Alternate exterior angles, B, outside the lines and congruent. Corresponding, congruent on the same side. And remember that one is one inside and one outside. And do it again. Oh, what's wrong with this board? Sorry. Okay, associative. Associative is who you hang out with. So A plus B plus C. Or the B could hang out with the C. And that's okay. Commutative, which means to move. X plus Y is the same as Y plus X. You can move back and forth. It doesn't matter. Distributive, 2x plus 4 is equal to 2x plus 8. Reflexive, something is equal to itself. Transitive, x equals y, if, and y equals z, then x equals z. Kind of, we talk about electricity or cooties. Substitution, 2x minus 4x can be written as negative 2x. We can substitute this for this statement. Okay, proof for the algebra. So given 3x minus 4 plus 5x equals 4x minus 3. Given. So the first thing we're going to do is distribute the 4. So 3x minus 4 plus 5x equals 4x minus 12. That's the distributive property. Then 8x minus 4 equals 4x minus 12. You could call that combining like terms. You can also call it substitution. Because you're substituting 8x in for 3x plus 5x. We just talked about that above. But if you put combining like terms, I would have taken that. Then we're going to minus 4x, which is the subtraction property. Which gives us 4x minus 4 equals negative 12. Then we're going to add 4 to both sides. So that's the addition property. Then 4x equals negative 12. And we're going to divide by 4, which is the division property. And that gives us x equals negative 3. Check. Sorry. That should be negative 8. I forgot to change it, which gives us negative 2. Check. Sorry about that. Brain wasn't working for a second. Negative 12 plus 4 is negative 8, not negative 12. All right, another proof. Given that these are all parallel, so A is parallel to B, and M is parallel to N, parallel to P. Given. Prove that 2 is congruent to 15. So we're going from here to here. So there's a lot of ways to do this. We can go 2 to 11, alternate exterior, and 11 to 15 corresponding. Or we go 2 to 10 corresponding, and then alternate exterior. It's pretty much the same thing. It doesn't really matter. So I'm going to say angle 2 is congruent to angle 10. Okay? And remember, if lines are parallel, then corresponding angles are congruent. That's about as short as you can make it. And then angle 10 is congruent to angle 15. If lines are parallel, then alternate interior angles are congruent. And now we can say angle 2 is congruent to angle 15 by the transitive property. Okay, if angle 2 is 120, then angle 8 is also 120 because they are alternate exterior angles. 11 is 111, then 20 is going to be the supplement 69 because 11 is the same as 15, 15 is the same as 19, and 19 and 20 are supplementary. Therefore, 11 and 20 are supplementary. If 24 is 94, right there, what's 14? Well, 24 and 16 are the same. They're corresponding. One inside, one outside. 16 and 14 are supplementary, which means 24 and 14 are supplementary. So that's 86 degrees. Angle 19, 95 degrees. Right here. Angle 7, right here. These are consecutive interior angles, which means they are supplementary. So 95 plus 85 is 180. Angle 14 is 78. Angle 15 is 78 because they are vertical angles. Angle 4 is 33 degrees. Angle 19, which is over here, okay, well, angle 4 and angle 6 are supplementary. 6 and 19 are equal, which means 4 and 19 are supplementary. So 180 minus 33 is 147. Let me walk through that again. 4 and 6 are consecutive in angles, interior angles. So if this is 33, this is 147. And 6 and 19 are alternate interior angles, therefore 19 is 147. Okay, solve for x. This printing is a little screwed up. So we're solving for this angle here. This is 2x plus 12, and this is 3x plus 8. Well, obviously they form a straight line, so they're supplementary. So 2x plus 12 plus 3x plus 8 equals 180. If you combine like terms, you get 5x plus 20 equals 180. You subtract 20, you get 160. Divide by 5, you get x is 32. So, angle A 32 in right here. 2 times 32 is 64, plus 12 is 76 degrees. Okay, these two, this should be over here a little more, and this should be right there. They're vertical angles. They're equal to each other. So we set them equal to each other. 3x plus 4 equals 5x minus 8. Subtract 3x, and I get 2x. Add 8, I get 12. X is 6. Now, I want to measure of angle B. Well, again, this angle and this angle are alternate interior angles, which means if I plug 6 in here, I'll get the measure of B. 6 times 3 is 18, plus 4 is 22 degrees. And I'm just going to go on to Unit 3 on this video to get it finished. Okay, angle O is congruent to angle A. MN is congruent to angle DY. OM is equal to AD. Well, if you look at it, we have angle, side, side. Or side, side angle. That is not a rule, so not possible. Immediately I know that's equal to itself. I also know RC is congruent to SK. So I use 2 lines there. And RS is congruent to CK. So what do I have? Side, side, side. Now, RSC. I start at R, go down highway 3, across the middle, diagonal. So I'm going to start at K, highway 3, across the middle. K, C, S. Okay, next one. We're told that M and J are congruent to each other. We also know that this is congruent because of vertical angles. So what do we have? Angle, side, angle. Now we have MKC. Outer road, no markings. Okay, start at the 1 arc mark. So outer road, no markings, start at the 1 arc mark. JPC. Try to prove. Okay? So, we're given that T and B are the same. We know that these are the same. We'll have to prove that. Also, RS and SU are marked congruent. So here we have angle, angle, side. That rule works. So we do our given. Measure of angle T is equal to measure of angle B. And RS is congruent to SU. Given. Now, we have to mark what else we wrote down there. And that really is just the vertical angle. So I'm going to start at B, arc mark 1 to arc mark 2, BSR. Angle BSR is congruent to angle arc mark 1, arc mark 2, TSU. That's the definition of vertical angles. At that point, we can say a triangle VRS is congruent to triangle TUS pi AAS. Okay, JT is congruent to NT. JN bisects CH. Remember, this is the one that's equal, cut in half. So CH we mark this way. Now we already know JN is split in half, but if we didn't say that, we couldn't mark it. And then we know this is vertical angles, so we have side, angle, side. So we write T is congruent to NT, and JN bisects CH, given. We're trying to prove an extra part, so we know we have to prove the triangle is congruent by SAS, then use CP, CTC. So therefore, I'm going to say, besides the sides that were given, the bisect, we have to prove what that means. So we're going to say that CT is congruent to HG, definition of bisecting lines. Then we say JTC, angle JTC, again, highway 1, highway 2. So highway 1 would be NTH, and that's by the definition of vertical angles. Now, I have enough to say that triangle, I use the same order, JTC, is congruent to triangle NTH by SAS. And then I can say CJ is congruent to HN by CPCTC. And believe it or not, that looks like that's the end. Oh, yep, it is the end. I just